for the lesson. There's no need to watch the recording, it's fine. So this is lesson 2, geometric sequences. What is a geometric sequence? Quite often, we're just trying to recap what we know already. A geometric sequence is formed by something each term. Multiplying, yep. Multiplying each term of the sequence by a constant amount. That constant amount is called something starting with C and something starting with R. Good, yep, common ratio. It's good just to get used to the terminology because they will ask for this kind of stuff in the tests. They'll say in the exams, they'll use the word common ratio and R. So you've already realised what that one was. The common ratio, R, can be positive or negative, but not 0. What would be a problem if you multiplied by 0 each time?
Then you just have 0 to add.
Yeah, then it's not even a sequence anymore, it's just 0. Yeah, so how would you say that? How would you write that in words? But not 0? So specifically why not 0? I guess you could say this in your own words if you want. So it would mean the sequence would look like this. The sequence might look like this, for example. I don't have much space to write that really. You can write this in your own words if you prefer. Look like this. Which doesn't really make sense. Like say if you had first term 2, if the common ratio was 0, then you just get 0, 0, 0, 0. So basically the common ratio can be positive, can be negative, because you can multiply by a positive or a negative. It just can't be 0, because then you wouldn't have a regular looking sequence. It'd be a bit of an odd looking sequence. Some examples of geometric sequences. 1, 2, 4, 8, 16. So U of 1, can you remember what the U of 1 is? First term, yep. So just like before, it's the first term. Feel free to fill in all the first terms if you like. And then we can work out the common ratios. What are we multiplying by for the first one? 2, yeah. And if you're down, if you can't see that, you can just think, okay, what's the reverse? If you had to divide to go this way, what would you be dividing by if you went in reverse? You'd be dividing by 2. So going this way, you're multiplying by 2. So common ratio is 2. The next one, what's our common ratio? 5. 5, yep, right, 5. Again, if you notice, I made a mistake in any of these, and like the last one doesn't work, as it happened in the last lesson. Let me know. We can fix it up for future generations. 2 times, and then 2, negative 10, 50, negative 50. Yeah, and you're right, because multiply positive by negative, you get a negative by negative gets positive, positive by a negative. Yep, so you're right, negative 5. If you had trouble seeing that, you could think, what's 10 divided by 2? It's negative 5. 50 divided by 10, negative 10. It's negative 5. You could say a decimal or a fraction for this version. Yeah, we're halving it each time. Good. So you can say a half or you can say 0.5. So a common error is some people might think you're dividing by 2, so they say 2. But we're doing the reverse, we're multiplying, going this way. So we're multiplying by a half. So as we said, they can be positive, negative fractions, just can't be 0. Like we had to prove that arithmetic sequences were arithmetic by doing like the second term minus the first term, and the fourth term minus the third term, and the 6th term minus the 5th term. The way we can prove something is geometric by taking the second term, dividing, like the common ratio should be constant, so the second term divided by the first term should be the same as the third term divided by the second, and the fourth divided by the third, and the nth term divided by its previous term. So you can call that its previous term. So for example, common ratio of a half, second term divided by the first term gives you a half. Third term divided by the second gives you a half. So when you're asked to prove something's geometric, probably like 3 proofs would be enough. Let's go back to here. Prove this sequence is geometric. So it's very tempting to just think, just do this.
It's previous term.
Yeah, it's previous term. Doesn't make any sense. So it is tempting to just say, hey, it's easy, times by, or what are we multiplying by? 3, yeah. But to do it formally, we kind of need to set up something like that. So the common ratio, yeah, 6 over 2, for example, equals 3. Good, yep, 18 over 6 equals 3. And a third proof, 15 after. 15 out 4 over 18 equals 3. So as we said, 3 proofs are enough. But 1 proof is probably not enough. You could always go more than 3 proofs, but at least 3 proofs. Just in case you're ever asked to do a little show that question. SL exams love show that questions where we already know that it's geometric, prove it somehow. And so like, this is an example of how you could do a show that question, show that this is geometric. Whereas in math studies, they don't have as many show that questions. Prove that this is true. So again, we've got versions where, is this the right page? Yeah. Okay. We've got versions where maybe the sequence is written in algebra. First term, second term, third term. So they're told that they're consecutive terms, so one after the other, of a geometric sequence. So find K. So remember they've got a consistent R. When it was arithmetic, we had to do that term minus that term and set it equal to that term minus that term. But this time, because it's geometric, it's that term divide by that term and set it equal to that term divide by that term. Minor, that won't be out there. It's not going to make it there though. So 2K, second term over the first term, must be the same as the third term over the second term. Because we're dividing its common ratio. So feel free if you want to write an extra thing. Second term over the first term is the same as the third term over the second term because of the common ratio. And then it's just a pure algebra problem. How would you solve for K? Cross multiply. Perfect, yep, cross multiply is where you would begin here. But we love our cross multiplication. So as I said, algebra is more algebra. SL is a bit more algebra intense too. So you're more likely to have a lot of problems like this. So what is 2K multiplied by 2K? 4K squared. You cross multiply the way you've done it. You don't have to write it my way, as long as we get the same final answer. And then we've kind of got something like this: 21 minus K multiplied by K minus 1. So now you can also see why we kind of made you do that presumed knowledge test again. Because what kind of, we could possibly end up with a quadratic equation that we have to solve. Okay. So you do the quarterly business. Don't need to show these expanding things if you don't want. So you go ahead and you solve this the way you would do it. I'm not concentrating. Never race. I'm going to do it that way. Oh, you get sevens too. Violent. We'll see, hopefully you got the same as me. Okay, I'm not concentrating, so if I do boo-boos, feel free to point them out. Doesn't look nice. It's possible, but it doesn't look nice. So we'll see if you get the same equation as me. Minus 20 minus K squared plus K. Just looks unpleasant. So we would have to solve with, you could do splitting method maybe, but a quick way to solve that, imagine if it was one that couldn't be solved with the splitting method. What's a quick way to solve for K? Oh yeah, imagine if it was non-calculated. Wouldn't that be horrible? Yeah. Yeah, quadratic formula is probably recommended. So that's why, as I said, presume knowledge is so important. Did you guys get roughly the same equation as me? I hope, because I haven't been concentrating at all. Okay, so we can solve with the quadratic formula. Let's practice that. Quadratic formula. And we might just have to leave our answers in as exact values, like third form. So quadratic formula. I would write out A equals 5, B equals negative 22, C equals 21. And let's fill it all in. Yes, aren't we? Negative 22 squared is pretty mean though. 5, 1, 2 times 5. Equals 22 plus or minus 22 times 22. 22 times 20 is easy. And then just add 44 if you want.
So 264.
Is it? Oh, actually a bit higher. 22 times 20. What would that be?
40, wait, 440.
440?
So 484.
Yeah, because add another 44. Yep, so 484, good. So we've got 484 here, minus that thing, over 10. Sorry, I'm running out of a bit of space here. Did I do a boo-boo? Yeah.
For multiplied by A multiplied by C.
Oh! Yeah, not 1. Ew, yeah, thank you. Thank you, Grace. I don't know where I got 1 from. I think I saw that. I didn't go beyond it. Thank you, Grace. So I will change that to 21, because that's 21, not 1. Cool. So then we've got 484, and then 20 times 21 would be
3.
Yeah. So this is like 20 times 21. 420. Yep. So we're going to turn that into a smaller number at least. Over 10.
Yeah, that is.
So well picked up on that. So then we've got 22 plus or minus square root of 484 minus 420. That'll give us a nice square number. Yeah, so we might get a nice whole number. If only we had the space. So basically you're going to end up with, you know, that's 8. 22 plus 8 over 10. Running out of space. I'm saying x, it should be k. Don't worry about changing it if you want. Yep, so 22 plus 8 over 10 is 3. What about 22 minus 8 over 10? Give us a decimal.
What can you 1.4?
What does that?
Will be 1.4.
Oh, 1.4, yeah, because 22 minus 8 gives us 14. 14 over 10, 1.4. So, Lauren, if we happen to suddenly be magically given a calculator, what method would you use to check that that answer is correct? Yeah, with a calculator. What's a nice cheating little app that we use? Polysmall, yeah. So we can kind of, if you want to, feel free to remember how to use Polysmall.
What?
We can throw our Polysmall on the graphing calculator. It's a little app. We can show it to you. So this is worthwhile because then we can teach you Polysmall. It's a cheat method. So if you know your original equation, like your original equation here, you can just plug in these 3 numbers and it's going to tell you what the answer should be. So we've done it as if it was non-calc. So this, by the way, probably a splitting method would have worked. So there must be a number that multiplies to give 105 and adds to give negative 22. But that's a bit of a pain to work out, just because of the fact that these numbers came out like that. But there might not be, so quadratic formula is just a quick method to get straight there. So feel free to change these to k if you want. It's not a big deal if you write x, because then you understand where it's coming from, the quadratic formula. But in your final answer, you just would want to write k. Okay, so do you have your cracking calculator here, Krista?
I don't have
Oh,
one. I'm
you
working
don't
on getting one.
Oh, you're working on getting one. Okay, cool. So we can show you when you get one how to use Polysmalt. So you would just plug those three numbers into Polysmalt. Remember, you go apps. Is it Polysmalt 2? Is that what it's called on yours?
It's like the third one down.
The third one down, whichever one. It is Polysmalt 2, yeah. Polysmalt, the 2 version. And you would select Polyroot Finder, and then put in 5, -2, 22, and 21. And hopefully we get the same answer. So that was a pretty vile one. So now another one might be a bit easier this time, just because the 3 terms are a bit easier. First term, second term, third term. Find k given that these 3 terms are consecutive terms in a geometric sequence. So second term divided by the first, k over 4, equals the third term divided by the second term. And like Krista suggested before, it's a cross multiply. You can write that if you want. That sums that. Feel free to go ahead and just do it, and we'll see if we get the same answers. Are you getting like 4 over 3 square root of?
Wait, how come?
Yeah. And how
Wait,
could, yeah.
What did you do?
And that could be simplified one more in terms of circuits. What's that, sorry, Krista?
What did you do after 4 equals 3k squared?
All right, I divided both sides by 3. So kind of like to solve for k.
Okay, yeah.
Yeah, you could have used this and done quadratic formula, but when it's something like this, it's not a difference of squares anymore. So it's not a difference of squares. So I just go straight to kind of like solving it this way. You can also do quadratic formula, where a equals 3, b equals 0, and c equals -4. And this is pretty close, but according to Surds, that could be simplified a little bit.
Ooh.
Yeah? Someone, yeah, it's the same as square root of 4 over square root of 3, yeah? Which is 2 over root 3. And what's yucky about that answer?
You have to do times root 3 over root 3?
Yeah.
This is so easy.
This is not nice, is it? Yeah, this is not nice. So k equals 2 over root 3. And k also equals -2 over root 3.
Wait, so you after you did 4 equals 3k squared, you just switched to k and made 4 over 3?
Yeah, I did. But
you
could
do that?
Yeah, you could. Yeah, you can just flop them over.
Oh.
Yeah, but you didn't have to. You could have just left the k on this
I
side.
like it on the other side.
Yeah, leave it on the other side. No problem. Yeah, we need to rationalize the denominator.
You did root 3 over 3, right?
Yeah, good. Yep. So that's a good idea. So now maybe we want to write now rationalize the denominator. It's like simplifying fractions. It just has to automatically be done. So you would multiply both sides by root 3 over root 3. So same with this one, times root 3 over root 3. So hopefully we're at the final answer now. So k equals...
So k has 2 by its 2 over root 3 and -2 over root 3.
Yeah, correct. Similar to like when you factorize a quadratic, quite often there's 2 answers. Did you get 2 root 3 over 3? and also k equals negative 2 root 3 over 3. Again, we could check our answers with polysmall, if we could be bothered. So that's pretty rough. Always good to check, like, is that all they asked for? They only asked for k. Find k, same with the one above. I hope. Find k, good, thank goodness. Because sometimes they then want you to sub k in to the original 3 terms and say what they were. So luckily I just went back and checked and it just asked for k. So again, like proving like how much algebra knowledge is required in SF. Like you're required to rationalize denominators all the time, simplify surds, quadratic formula kind of stuff. Be able to factorize really easily. Yeah. And do you know why in maths generally, why you're not supposed to leave a third in your denominator? Have you been explained that at all? It's kind of interesting. Like, there's just one, because really, what's wrong with that? And there's just one theory that I found by looking into it was back in the old days when it was pre-calculator days, you can kind of reasonably easily come up, like find hands without calculator, try to work out this, because dividing by 3 is not such a hard thing to do, but dividing by something like 1 point blah 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 is really hard to do. So that's why it's all a bit of a hangover from the non-calculator days. So it's, in a way, it's one of those kind of maths that's kind of maybe a bit obsolete these days. But it's still because it's been around for so long, it's just it's a tradition we have. Because by hand, you could easily calculate that by hand, but to calculate this by hand is really hard, like dividing by something with an infinite amount of decimal places. Multiplying by something with an infinite amount of decimal places, you could get pretty close to the answer pretty easily. But so long as you know how to simplify, so you're good. Okay, example. A sequence is defined by 6 multiplied by a half to the power of n minus 1. State the values of u of 1 and r. So looking back on your formula booklet, there is a formula for the u of n. And do you remember what it is?
U of n?
Yeah,
Oh.
for the geometric sequences in your formula booklet. Which is also one of the, like it's on one of the earlier pages, like page 3 or something of your booklet, your notes. Do you want me to just tell you what it is? It's u of 1 multiplied by r to the power of n minus 1. So that's what appears in your formula booklet. That's the magic formula for a geometric sequence. That's how you would find the nth term. You might remember doing that in year 9 as well, or in GCSE. You probably used something similar, but perhaps you didn't use those. You were just told the first term multiplied by the common ratio to the power of n minus 1. So that happens to be what that looks like. So this is from formula book. Just in case you ever look back and you wonder, where does that come from? That comes from the formula booklet. So the way this is being presented, what would our u of 1 be there for? 6, yep, we just look at what's in there. Yep. What would our common ratio be?
2.
Perfect. Yep. Because that means the first term multiplied by the common ratio to the power of n minus 1, which follows the formula from the formula booklet. And then find the 16th term, choose 3 sig figs. That's a bit of a clue maybe that it's a calculator question. So they just want us to sub in the u of 1. And what would our n be? 16 exactly. The 16th term. So just find the u of 16. U of 16 will be the u of 1, 6, multiplied by a half, all to the power of 16 minus 1, according to that rule. And it's with calculator, so you could plug it into a calculator. And I don't have a calculator here, so I might have to rely on someone else.
I got 1.83 times 10 to the -4.
Which is possible, could be a really small number, because you're halving each time. The common ratio is a half, and you're halving each time, so the 16th term could be a really, really tiny number. Yep, so 1.83 is the part that's rounded to 3 sig figs. times 10 to the negative 4. So does anyone else get a different answer? No. Do you want the AC on? Yes, yeah. Then it gets hot suddenly. When it gets too cold, let me know and we can switch it off.
I got it written in.
Expand
I got
that?
but
That's
in
fine.
the standard form.
Yeah, it's in standard form. Yeah. You could have written it as a decimal as well. You could have written or 0.000, actually out of interest, where would I put 1 now, or should I put another 0? 183? Yeah, because that's times 10 to the minus 4. Yep, so both forms are okay. Standard form rounded to 3 sig figs, or the expanded form rounded to 3 sig figs. Both are fine. That's a nice straightforward question. Another example, a geometric sequence has a first term of 4. So when I see that, I just go straight to writing this out. So it's done. I've realised what that is. And a common ratio of 3. Start to generate kind of lists of information. Because sometimes those lists can inspire you to come up with a solution. Which term of the sequence is 324? So they want to know, is it the 6th term? Is it the 7th term? Is it the 8th term? So they want to know what the n is. So n equals question mark. And they've kind of told us what the u of n is.
So
what's the n value if the u of n is 324? What's that? So you could just use the nth term rule from the formula booklet, because you know that number, you know that one, you know that one, and we're going to have to solve for n. You might need to use something like logarithms to do that. So our general formula, u of n equals u of 1 r to the power of n minus 1. That's just how it's written in your formula booklet. They don't put in a multiply sign. And then we can plug in these numbers. Yeah, exactly. Because you're going to get a good mark just for plugging in the numbers in where they should go. That's definitely going to get you a mark. U of n equals, then the u of 1 is, yep, good 4. And if you want to, you can put a multiply if you prefer. If it helps, or you can put brackets. 4 multiplied by 3. It's not wrong if you're at 4 times 3, but you can do it like that too. And n is what we don't know.
love this picture. This one.
This one?
This picture, I really like it.
It's a nice photo.
Yeah, I love her.
She's very cool. Has she ever come to Bermuda? A long time ago?
I wish she would come again.
So, what was I going to remember? Oh, right, now, do you remember in CIE or whatever course we did, that doing something called logs? Yeah, remember, logs can solve for unknown exponents. If this was a calculator problem, to be honest, you could just graph this, and then graph this, and find the point of intersection. Have you learned to do that? Like graph a line? Okay, let's do it with logs then. That's even better. Because we need to make you guys really good at logs. So to solve for an unknown exponent, we use logs. But first of all, we've just got to get this by itself to begin with. This part here, that part. So how can we get rid of the 4 here? What do we do to both sides?
This is log?
Yeah, divide.
Oh my gosh, I
It's good that you've heard of them. It's important. So you're going to get really good. Yeah, exactly. So 324 over 4 equals 3 to the n minus 1. And now it's from here you can start to use awesome logs. Do you remember, like, when you've got your unknown exponent, that you would log both sides? Yeah. So it was a resentful yes, like, thanks. Don't want to do that. If you know what 324 over 4 is, yeah, it's better, isn't it? Don't have to write. You could just write 324 over 4, but if it's 81, let's write that. Equals log of 3 to the power of n minus 1. And do you remember a special log law that enables you to do something with this? Yeah, good. Exactly, you can. All of this can go out there. So you don't need to draw the green stuff if you don't want. So log of 81 still going on here. Equals, and I'm going to put an error in mine so you can sort of see what the error is. Minus 1 log 3. So mine's missing something. Brackets, yeah. Because all of this got multiplied out the front. So I need brackets here. That's what loads of people forget. They forget those little brackets. Because if you didn't have brackets, only the ones multiplied by log 3. But now both things are multiplied by log 3. And different ways you can solve it. You might just want to divide off the log and then add 1. So you might just want to divide off log 3 and then add 1 to that answer. You might prefer to expand first and then do all that business. Looks like some of you are keen to just divide by log 3 to begin with. Log 3, no, log 81, what am I saying? Log 81 over log 3 equals n minus 1. 81, would you agree? It's a power of 3. It's 3 to the power of what? Equals 3 to the power of? Oh yeah, 3 times 27.
3
Close?
times 3 to the power
Close, that's 27.
3 to the power 4.
Yeah, 3 to the power of 4. So 81 happens to be 3 to the power of 4, because I'm just noticing if I change that to 3 to the power of 4, we're going to be able to times the 4 out the front and cancel off the log 3. Sounds horrible, yep. So therefore log, I'll just put that in green, 3 to the 4 over log 3 equals n minus 1 still. So all I've done is I've just realised 81's base 3, which is going to, if we can use a log law here. So Grace, what was the log law that you were mentioning about what you can do with it? Yeah. So that lovely 4 can go here. It's pretty rough. Sorry, I really don't give you enough space, do I? I need to give you more space. And working out log 3 over log 3. So see, something's going to cancel now. And it could be non-calc. Yeah. So isn't that awesome?
4, but it cancels out.
Yeah. So 4 equals n minus 1. So n equals?
5.
Yeah. N equals 5.
That's
pretty rough. But that was a good practice at logs, like it's got good background stuff in it. Have we finished that question yet?
No. What question?
Yeah, yeah, what question exactly? We need to therefore go back and find the first 4 terms. So we've just found that n was 5 for that.
So then we just sub in
And then to find the first 4 terms, it's easy. We just
U4.
use those things. All we're doing is, they wanted us to find n for this, but we don't then use that n to find the first 4 terms. We obviously know the first one's 4. You could easily just find them anyway. 4 times 3. Yeah, and so on. Did you know the general rule? The general rule is this.
4 times 3 to the power of
1 minus 1. Yeah, or for the first 4 terms. So the first term you would plug in n is 1. For the second term you'd plug in n is 2. Calculate that answer.
So then where does the 5 come into play?
The 5 was just totally to answer this first part, like part A.
So 324 is the 5th term.
Yeah. So in a way, that's like a part A and a part B. Part A and a part B, but part B was so much easier than part A. It's horrid. Yeah, you don't use your answer to part A to answer part B at all.
Yeah.
And if you know the first term's 4 and the common ratio is 3, that's a good way to do it. First term's 4, what's the second term? It'll just be 4 times 12. The third term will just be 12 times 3. I think it was initially I had this question written out as part A and part B, but then I thought you needed more space, so I squashed it into just one question. So that's done. And then on the side, yeah, have the other notes done that? Or is there another one for this topic?
We have 2 more examples.
2 more examples. Yeah, you can grab some water. So the first 4 terms, I'll just do it here. Terms are, because we know 4, and we know the next term is times 3. 12 36. Is it 198? Just because it's the common ratio is 3.
Oh.
Yeah, and the first term, so that was a shortcut. You could sub it into the formula I had written, but because we know that the common ratio is 3, then we could just do it that way too. And we were told in the question the first term was 4. Yeah, because 30 times 3 is 180, 6 times 3 is 198. 108?
Yeah, that probably makes more. Yeah, one.
Oh yeah, sorry. I have no idea. I did 30 times. Thank you. I did 30 times 6. Yeah, so 108. You're right, because 30 times 3, sorry, is 90, and then 6 times 3 is 18. So 90 plus 18. Thank you for this. So intense this topic. So much algebra. Yeah. Okay, just 2 more examples. Is anyone writing still? Yeah? Do you want me to go back?
So much.
Oh no, I'm
You're fine?
So much.
Okay. Find the first term of the sequence, 5, 10, 20, 40, which exceeds 10,000. Okay. So, first of all, what's our U of 1? That could be a good start. Did someone say it? 5, yep. What's our common ratio? We can work that out.
5.
Yeah, so we're doubling each time, good. And find the first term of the sequence which exceeds 10,000. So that means our U of n, we set it being 10,000. And we solve for n, just like we did before, we're going to solve for n. Sort of. We can also do a bit of guess and check. So we're going to solve for n. And then they want to know which is the first term. So once we've kind of got our n, we need to decide whether we round n up to the nearest whole number or down to the nearest whole number, and then sub that into the general formula to see which is the first term that's bigger than 10,000. So we did a similar one with arithmetic sequences, where they were told which is the first one that's less than 4,000. So we had to solve for n if it was 10,000. You might not get a whole number. You might get a decimal. Like you might get the 30.7th term. But remember, it can only be a whole number because you can't have a 30.7th term. You can only have a 30th term or a 31st term.
Yeah, so it would be.
Yeah. So in this case, you'd probably then have to round up to the 31st term. So it's saying which is the first term that's going to exceed this number. So if it helps, our general formula we're using is U of 1 r to the n minus 1 still. So we're still using that general formula. And we're going to sub in these awkward numbers. 10,000 equals U of 1, which is 5. If you like, you're welcome to use multiply sign. You could also use brackets instead to say times the common ratio.
Wait, but how come you put U at equals 10,000 and you went to exceed 10,000? Or just using that as like a starting point?
Yeah. Yep. So what we're going to do is we're going to find approximately what n value would hit 10,000 exactly, and then we use that to either decide, okay, should we round that n up or down? And in this case, we're going to need to round it up because it said the first term that's going to exceed 10,000. And then we'll solve for the n, and then to find, because it's not saying which term, which position number, which term. So then once we've got the n, we're going to have to sub it back into here to get the actual term. Like it might be 10,025 or something like that. Different ways you can do it, but we'll try practicing our algebra way as well. So let's try solving with logs again. So before we log both sides, what do we need to do to both sides? What's to do with that?
Multiply.
Divide by 5. And to save you a bit of space, I'll accept what is 10,000 divided by 5. We can go straight to the answer if you want. Yeah? Someone just said? 2,000, yep. So 2,000 equals 2 to the power of n minus 1. So if you want to write a note, you could say divide both sides by 5. And now, luckily, we can log both sides. We can get a log of 2,000. This happens sometimes. I just have to pause the video to record. Cool. Okay, so see, I was trying to write over it, and so it does that. So now log of 2000 equals, if you're comfortable with doing that, you can go straight to this. Yeah. Yep. So if you're comfortable going straight to using the rule that Grace mentioned, you can do that. Sometimes people like to do that. Then would you agree that it's like, yeah, the brackets are exactly, because if you don't have the brackets, technically it's not right. It would be just -1 times that, and then n minus that. You could expand now if you wanted to. You could expand, or you could just divide off the log. Log 2000 over log 2 equals n minus 1.
2 to the what is 2000? 2 to the.
Oh yeah, so just wondering, yeah. Might not be a power of 2, but it could be like a power of 2 multiplied by something, another power.
Like 10 to the power of 3, or 2 times 10 to the power of 3.
10 to the power of 3, 10 cubed, yeah, that's possible. Log 2, and then 2, yes, Grace?
Wait, what would happen if you didn't make it the same way?
It wouldn't matter. If it was with calculator, I would just do it with calculator.
So you could just divide it?
Yeah, I would say this one would probably be with calculator. This would be pretty mean. The one on the previous page, you could have done non-calc, but this one would be a bit mean to do non-calc.
And then just do 2000 divided by 2.
Yeah, and then just add 1 to the answer. So shall we do it just like that? We'll assume it's with calculator.
That's, we can divide it, okay.
Yeah, because that would be pretty mean. To expect you to then separate this out into log brackets 2, was it times 10 cubed, and then kind of have to like rewrite that out as log 2 plus 3 log 10, in which case it might not really simplify that much anyway. So you'd be forced at some point to use calculator. So yeah, I think we'll do this one with calc. Over log 2, and then plus 1 equals n. So we'll say with calc for this one. Realistically, I think that one would be with calc. And then it's just a matter of are you typing it into the calculator accurately. And I don't have a calculator here, so I'll rely on someone else to do it. You might want to make sure to use your nice fraction button. Like, you know how you go alpha y equals to make a nice fraction box. Do you have another way to fit into the fraction button? Yeah, that's it. Alpha y equals Z. So you know that one too. Alpha y equals n slash d generates a nice fraction box. And then plus 1. That's the safest
I
way.
think mine was right.
And then we're almost done.
It's n equals
11 point.
n equals 12.
Oh, but we're going to have to round up anyway.
11.965784.
Yeah. So I'll just do that dot dot dot. So we're asked which term is going to be the first to exceed. So would you agree it's not the 11th term, it would be the 12th term? Because if you sub in n equals 11 into your original formula, then you'll probably get a number less than 10,000. We need it to be the first one above. So n equals 12. So you might want to say, so use n equals 12. So use n equals 12 and sub it into our original equation to get our u of n. So u of n equals, you can say u of 12, is it first, and then after all that, 5 brackets 2 to the power of 12 minus 1. And hopefully it's a number kind of just above 10,000. If we get a number that's like ridiculously above 10,000, we'd assume something like that. So we get something nice.
I got 10,240.
That sounds good. 10,340.
200.
Wait, so you
Oh,
just,
240,
you just
sorry.
rounded up to 12, you didn't bother to go to 11.
Yeah, exactly. Because if you plugged in 11, then you'll probably get a number less than 10,000. And if you're not sure, try to do that. Try to plug in 11, and you'll probably find you get 9,000 something or 8,000 something. So and the question says, what's the first term that exceeds 10,000? So loads of work involved there. There is ways that you could have just solved this by graphing. You could have graphed that and then as an equation, like graphed a straight horizontal line and graphed this equation on the same axis and found the point where they intersect, found the coordinates of the intersection point, and then that the x value would have been the end. That's another way to do it. But it's good to practice with.
Yeah, like I got 5,000. When I just got
There's
into
lots of
11, I got
things.
5,000.
With that? Oh, you got 5,000. Okay. Yeah. So yeah. So it makes sense that it has to be 12. We had to round up, and because n needs to be a whole number. Like you can't have an 11.96 term in a sequence. You can only have an 11th term or a 12th term. So n values have to be positive whole numbers. Can you remember what's the name of the subset of positive whole numbers?
The subset.
Yeah, like is it integers? Positive whole numbers generally equal something starting with n. It's with trees and leaves and stuff. Flowers.
Oh, what's that thing? The Fibonacci?
Close. N starts with n. With something numbers, types of numbers, not integers, because integers can be positive and negative. Natural, yeah. Just reminding you of number subsets from the past. Natural numbers are like positive integers generally, similar to positive integers. Integers in general can be positive or negative, but natural have to be positive. Okay, last example, yeah. A geometric sequence has the second term is -6 and the fifth term is 162. We had a similar one with arithmetic last lesson, and we had to generate two equations and solve them simultaneously. So same thing with this one, we'll generate two separate equations. And so to find the general term, we need to know the u of 1 and the r. So the thing we're going to need to solve for is the u of 1, question mark, and the r. So generate two equations, and we'll see once we've generated the two equations, how can we solve them? So from that one and from that one, we're going to generate two equations. That's the second term, that's the fifth term. N equals 5 for that one, n equals 2 for that one. So u of n, and we're going to use a general rule, u of n equals u of 1, r to the n minus 1. So they're the equations we're going to use. We're going to set up two of them and see how could we possibly solve for u of 1 and r once we've got them. And so we can say u of n -6 equals u of 1, which we don't know, multiplied by r to the power of 2 minus 1. You can go straight to saying 1 if you prefer, but I'll just show this as an initial step. 162 is our u of n equals u of 1 multiplied by r to the power of 5 minus 1. And then I'm just going to simplify that. -6 is u of 1 r to the 1, or r, you could say u of 1 r to the 4. So that's just like saying r really, but I'll just leave the exponent there. So how could we solve? I'm going to suggest, do we multiply one equation by the other? Do we add them together? Subtract one from the other? Divide? And try to make something cancel out? Similar idea to simultaneous equations. Well, we want to either make the u of 1 cancel out or the r cancel out to begin with. Yeah, good. Yeah, so you could do that equation, divide by this one. So we can, yeah, because when you divide, when you do that one, divide by this one, u of 1 is going to cancel out. And remember exponent laws, index laws? R of 4 divided by r will become r cubed. Yeah?
Have the equation and then something like 6.62 equals u1 r4 divided by another equation.
Yeah, so you'll have a denominator, will be this, divide by the numerator, and you'll find things will cancel down.
Wait, what's the denominator?
sorry, the denominator, the numerator, denominator. Yep, sorry, I said it the other way around, didn't I? So let's put this one, 162 equals u of 1 r to the 4. And let's put that all over. So divide the equations and cancel it out. Whereas with arithmetic sequences, it was more set up to do like elimination, regular simultaneous equations. Because there was something like u of 1 plus d. And the second one is, oh my God, okay, negative 6 equals u of 1 r. So what completely cancels out? Krista?
You cancel out the u on u1.
Yep, good. And you would have to work out 162 divided by negative 6.
Negative 27.
Sounds good. So if you want a middle step, feel free to do 162 over negative 6 equals r to the 4 divided by r. Would you agree with you? Yeah, good. So that might be helpful to look back on and see that initial step. And as Chris has said, this turns out to be negative 27 equals r cubed.
So
And
that you cancel.
yeah, how do we solve for r now?
But can we do it there because you can't have like the cube root of a negative number?
Actually, that's a very good point. You can have a cube root of a negative
You
number.
can,
Yeah, you can't have the square root.
but you can have so it's
Yeah.
just negative.
Yeah, negative 3. Does that make sense? Negative 3 cubed is negative 3 times negative 3, which is 9. And 9 times negative 3 is negative 27, yep. So,
You can't have
yeah, you can have an odd root. You can have an odd root of a negative number. You can't have an even root of a negative number. Because a negative times a negative gets a positive. So, we've got our r, isn't that awesome? Now we just need our u of 1. Or do we know what u of 1 is? Oh.
Yeah.
So to find the u of 1, just choose one of the equations and sub it in, yeah. Ah, that's actually much smarter. Yep, so Kies has come up with a quick way to find u of 1. If we know r, Kies has remembered that we know what u of 2 is. So the first term must just be the term before that. And if the common ratio is negative 3, it must be divided by
Negative 6 divided by negative 3.
Yeah. 2, yeah. So that's much faster. A lot of work, isn't it? So the first term must be u of 2 divided by negative 3 if you want. Just make a little note to ourselves, a shortcut method to get the first term. So which is negative 6 divided by negative 3, which is 2. So the general term, the u of n equals the u of 1, which is 2, multiplied by common ratio, which I'll put in brackets. You could say 2 times negative 3 to the n minus 1. So what I'm giving you is kind of like examples as well of how bad it can get. So there's plenty of examples, especially in the textbook, plenty of examples that are just straight up sub it in, even just do a bit of basic solving. But I sort of need to give you examples of how to do the hardest ones as well. Okay, I can stop that now. So that was pretty intense.